if we have data on the same individuals before and after an intervention, or the same unit before and after a treatment or an intervention, we call that matched sample. The advantage of matched sample, as we've seen before, is that you have the same individual, so we can control for the unobservable things, and we can just see if the effect was due to the treatment itself for the same individual. So here's an example where we have a new diet. We measure cholesterol levels before the intervention and then after the intervention. And we hope to find that the new diet indeed lowers cholesterol. So on an average, you would expect the after values to be lower than the before values. So when we construct the test, we hope to find our alternative would be that mu1 minus mu2 is greater than d naught. Or in this case, because we have the same individual, we'll look at the difference between before and after, and we'll expect that to be positive. So if we reject the null, and we can hope to find that the difference before and after is positive, that means that the diet did lower the cholesterol levels. So let's see how we conduct this test in JMP. So we translate this data in JMP. We have before and after levels. So typically we have the same data on the individual before and after. Again, we want to look at before minus after. So we can actually create a variable which will subtract after from before. So it will be our mu1 minus mu2. To create a variable in JMP, or we can right click here, click on new formula column, or formula, and our formula will be before minus our after. And we will call this variable d, or d underscore I difference. So this is each individual's before and after results. Again, we are doing 1 minus 2, so we subtracted after from before. And now we can actually conduct a one sample test. We will use the t distribution to conduct this one sample test. So in sample index, instead of clicking on two samples, this time we will just click on test mean. We have the raw data. We will choose raw data. And it asks us what column contains our data. It is DI because we created DI as before minus after. Pick a column, click OK. Now this is a t test, so we'll choose t, and we are choosing a right tail test because we are hoping to find that our intervention or our diet has perceptibly lowered cholesterol. So I'll choose the option of right tail. Population mean is greater than the hypothesized mean value. And our mean, we'll just let that be equal to 0. And then the next thing we want to calculate is our significance level. And our significance level is 5%. So I'll put in 0.05. And once we have this, we get our standard error. We get our t-score. We also get the critical value of our t-score. And then we get our p-value. So our p-value is 0.013, which is less than our significance level of 5%. So we reject the null. We say that, yes, there's evidence that the difference between before and after cholesterol levels was on an average positive. So the new diet would have lowered cholesterol levels.